Hello and welcome to this Bioprocess International Ask the Expert webcast. I'm your host, Alex Nicolaitis, the webcast coordinator for Bioprocess International. Before we get started, just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We've muted the audio lines, but we welcome you to type in your questions for our speaker in the question and answer window on your screen. After the presentation, we'll begin the Q&A portion and I'll ask our speaker your questions. Your questions in the Q&A window will only be visible to myself and our speaker. So thank you for joining us today. It's now my pleasure to introduce our speaker, William H. Rushton, MS, Process Chromatography Support Scientist from Bio-Rad Laboratories.
Thank you very much for that introduction. Good morning, everybody. Today I'm going to be speaking about 5 essential facts about CHT chromatography media. Here is an overview of the topics that I will be covering in this presentation. CHT is the gold standard for impurity removal. It has a flexible method development, offering unique selectivities, a simplified packing method, as well as being a sustainable chromatography resin. We're going to begin by talking about CHT as the gold standard for impurity removal. I'm going to be talking about aggregates, leach protein A, endotoxin, DNA, as well as host cell proteins. I'm now going to do some brief introductory information on CHT about what it is. It is a matrix material, which is just crystalline mineral of calcium and phosphate. So unlike most other resins that you think about where you have your particle, base bead, and a ligand attached, with CHT, the ligand and the matrix are all the same. It offers 2 functionalities. As a mixed mode, it's calcium affinity and cation exchange. Popular applications are mAb manufacturing as well as vaccine manufacturing. It is also very good at aggregate and process impurity removal. It is available in 3 types, CHT type 1, type 2, and CHT XT. Now I'm going to talk about how CHT is a mixed mode by its very nature. So on the left, you see amino residues. They will be binding via classical cation exchange on those phosphate sites. In this situation, you're able to dissociate with salt or other buffering salts like phosphate. Additionally, you can weaken or dissociate with increasing pH. For carboxyl clusters, they're binding via calcium IMAC. These interactions are substantially stronger than ionic interactions, usually 15 to 60 times stronger. They won't dissociate even in 1 molar salt. You will require phosphate to get off of the CHT. And then finally, any phosphoryl residues, they will also bind kind of via calcium chelation. Again, very strong interaction, 15 to 60 times stronger than the IEX. In this situation, the sodium chloride will lead to stronger DNA binding. And again, it will require high levels of phosphate to dissociate from the CHT. Now I'm going to present a slide showing how CHT is the universal polishing media. CHT is unequaled in clearing the full range of impurities. The table below shows how aggregates, residual protein A, host cell proteins, DNA, endotoxin, and even viruses are able to be cleared from CHT. The observed clearances are between 1 to 4 logs, and in some cases even larger. These results are on salt gradients at a constant phosphate concentration. Now I'm going to give an example of a basic mAb aggregate removal. This has a PI of 9.3. The SEC of the load shows that there's 28% aggregate. The purification is a pH 6.5 in phosphate with a 0 to 1 molar salt gradient. The elution showing 0.1% aggregate after the elution with a purity of greater than 99% and a yield of approximately 68%. Now you look at that 68%, you have to remember there's only 72% monomer in the load, so the overall yield would be 94%. This slide showing the removal of aggregate using an acidic mAb of a PI of 6.9. So the SEC of the load showing 34% aggregate. This time the purification is run in a phosphate pH 7, same linear gradient, 0 to 1 molar salt. The SEC of the eluate showing the monomer content of about 96.9%. So you're seeing about a 90% reduction of aggregate across this step. I'm now going to move into showing how CHT provides flexibility in your method development and giving you the ability to achieve high purity product. Here we're showing simple bind and elute method development for some common applications. So if you have a protein with an unknown pI, you're going to bind between pH 6.5 and 7.5. Just note that higher pH stabilizes CHT particles. We also recommend having phosphate in all your buffers of at least 5 millimolar. For elution, you can elute either with phosphate or salt or both. You want to start out typically with a gradient, linear gradient, and then once you kind of see where your product comes off, you can then convert to a step. For basic proteins, since you're binding primarily to the phosphate sites, you can consider flow through for non-binding targets. When you're eluting, the elution of using sodium chloride may be more selective than phosphate, so you could try a linear gradient and then convert it to a step. Low levels of phosphate can eliminate the weak calcium interactions, so you can go with 5, 10, or even 15 millimolar. For acidic proteins, you're binding primarily to the calcium sites. So there you might be able to bind in a higher salt and allow non-binding targets to flow through. The elution, though, you're going to need phosphate by itself to elute. So you can do a 0 to 400 millimolar phosphate gradient and then convert that to a step. Salt might be helpful depending on the impurities that you're trying to separate. And then for regeneration, we recommend 3 to 5 CVs of either potassium or sodium phosphate, pH 7.5, and then you sanitize with 0.5 to 1 molar hydroxide. This is a virus purification of influenza virus on CHT-XT. So on the left, you can see the chromatogram of the process that was run. And then on the right, you have silver stain and immunoblotting assays of the fractions. So the protein bands show the active samples were detected by HA specific monoclonal antibody. And at the bottom, you can see the reduction of impurities. So you have 0.4 log reduction of double-stranded DNA, 2.8 log of total protein clearance, and a 2.5 log clearance of host cell proteins. Now we're going to show a virus purification of dengue virus on CHT-XT. On the left is the chromatogram showing the purification. On the right is STS page, silver stain, and an immunoblotting assay that was performed on the fractions. The assays determined that there was a log reduction of 1.1 of the double-stranded DNA as well as the total protein clearance across this step, which was a single-step purification. Now I'm showing a single-step plasmid purification. On the left is the chromatogram showing the linear gradient resulting in 3 unique peaks. Peak 3, after all the analysis was done, showed that it had highly purified supercoiled DNA. Now I'm going to talk about the ability of CHT to provide unique selectivities, which will enable fewer steps in the purification workflow, leading to improved process economics. So first I'm going to talk about going from a 3-step to a 2-step MAB purification. So the 3-step workflow is protein A capture, followed by a polish, which is typically an ion exchange of some sort. Polish number 2 can be an ion exchange or a HIC. So the 2-step workflow that we're proposing is protein A capture, followed by using CHT and its mixed mode ability to reduce the number of columns. So here are the final results of using CHT-XT in this 2-step process. So on the left is the SCS page, both reduced and non-reduced, and on the right is the SEC. And if you look at the table, the yield was 100%. The purity was 99%, and this was loading 25 mg per mil onto the CHT-XT. Now I'm showing the final comparison of the 3-step versus 2-step. So for the 3-step, we had the protein A capture followed by a cation exchange and an anion exchange flow through. The overall yield across the 3 steps was 91.6. Monomer purity was greater than 99.9. HCP was 3 nanograms per mil. and host cell DNA was below the limit of detection. For XT, the yield was 100%, the monomer purity was 99%, and you'll see similar HCP and DNA removal. So you're able to show in a two-step process, you're able to get comparable results to the standard three-step process. So now to summarize how this two-step workflow can help with your process intensification, you have an overall higher yield versus the three-step process and comparable purity. The unique selectivity of CHT allows for a single-step aggregate and HCP removal step. This then further reduces your QC testing as well as regulatory and documentation burdens. It requires less suite time since you're only using one column versus two in the downstream. It also leads to a cost reduction in operational units, labor, and capital equipment. Here's another study showing the unique selectivities of CHT. This is for a bispecific purification. 3 post-protein A bispecifics were polished by single-step CHT to over 97% purity and also provided efficient removal of both product and process-related impurities. You can see the reference down on the bottom if you'd like to see details of this study. Now what you're seeing is a chromatogram of the purification of 4 unique proteins across CHT. Here a linear gradient is performed after binding, and you can see that due to the unique selectivities of CHT, you're able to get really good separation of these 4 proteins. My final example showing the unique selectivities of CHT is to focus on the superior resolution that CHT provides. Here you see a chromatogram of a phosphate gradient, which is able to provide baseline separation of 5 isozymes. I'm now going to move on to speaking about CHT packing. It packs as a non-compressible resin, which makes packing easier than packing compressible resins in a column. Here's an overview on packing CHT. So first you need to make the CHT slurry. The bulk density is 0.63 grams per mil. What that means is that 1 kilogram of CHT will equal 1.6 liters of packed bed. When you're packing larger columns greater than 20 centimeter internal diameter, we do recommend using a value of 0.60 versus 0.63 due to losing the wall effect of smaller ID columns. You can slurry directly in the column, or you can use a slurry tank. If you're using a slurry tank, you can transfer it into the column using the following methods. You can manually pour it into the column if it's an open column. You can pump it in. You want to use a diaphragm pump. You don't want to use rotary lobe or peristaltic pump, as these can cause damage to the CHT particles. You can use pressure using a pressurized slurry vessel, or you could just use a suction or syringe method where you just draw it up out of the slurry tank using the top adapter to draw it in like a syringe. Once you're packing, once you get it all into the column, there is no compression factor. The compression factor is 1. Once it's packed, it is packed. It will not go any lower than that. You don't have to worry about rebound. And then you can flow via flow packing. You can do an axial consolidation where you're bringing the top adapter down to consolidate. You do a combination, which is an axial compression flow method. That is kind of one we prefer because you're able to use the adapter to lower that headspace, but also pack at the same time, which will reduce some buffers. You can stall pack, and if you really want to, you can actually just put CHT in the column, let it settle overnight, and come back and finish the next day. It won't impact the packing. You then qualify the standard method, salt tracer, to get your HETP and asymmetry. Now I'm just going to comment on some tips for CHT column packing. So our recommended packing buffers are 200 to 400 millimolar sodium phosphate, pH greater than 7.2, or 150 millimolar salt, also greater than pH 7.2. Several do's for CHT. One, you want to make sure the column is level. Since it is not a compressible resin, if you don't have a level column, you could have a sloped bed, which could give you differential separation. You want to make sure you only use plastic paddles or low shear hydrofoil impeller for mixing. As I previously mentioned, you want to use only a diaphragm pump for the media transfer, and you want to leave a headspace of 1 to 5 millimeters. This will then lead into some of the don'ts. You don't want to compress the head plate into the bed. If you do so, you could damage the particles, which could lead to increased pressure as the broken particles fill in those interstitial spaces. You don't want to run the column in upflow. Again, because of this headspace, if you run an upflow, the entire bed will lift up, and this would ruin the pack. If you need to calculate the amount of CHT and buffer for slurry preparation, this can be found on the CHT applications guide at bio-rad.com/CHT guide, or the chromatography calculators at bio-rad.com/calculator. Additionally, we have a couple of pre-pack column options. We have our Bio-Rad Foresight pre-pack columns as screening tools. These are 1 and 5 mil pre-pack columns. And then we have our process scale GMP ready Foresight Pro columns, which run from 5 to 33 centimeter diameters. Now I'm going to talk about how CHT is eco-friendly and can help achieve your sustainability goals. So now I'm going to talk to some of the sustainability aspects of CHT. CHT is shipped as a dry powder, which reduces material and handling costs. It's also non-hazardous, so there's no ethanol in the shipping solution since it is a dry powder. So it eliminates specified storage conditions for ethanol products and sending buffers to hazardous waste. CHT is directly slurried into the packing buffer, so that reduces buffer and water consumption, and it facilitates a faster packing operation. And finally, since CHT is just calcium phosphate, it is biodegradable. Continuing on with sustainability, by being able to reduce your number of process steps, you're able to reduce the consumption of buffers, water, and packing materials, leading to a sustainable workflow. This leads to a reduction of waste. It reduces your QC testing, regulatory, and document burden, which then allows you to have less sweet time, which in the grand scheme leads to a cost reduction in operational units, labor, and capital equipment. Now I'm going to talk about how our pre-packed GMP-ready CHT Foresight Pro columns can help with your sustainability goals. Bio-Rad provides one source of contact for supply, global technical support, and customer service. We have over 30 years of CHT packing experience, exceptional service, and a reliable supply of CHT to ensure your purification is successful. Additionally, it will lead to a reduction in resources to procure and transfer materials to other packing service companies. It will reduce resin materials and packing used on site for column packing, which then leads into less facility time and sweet time for packing. Additionally, you're able to eliminate the buffers and hardware required for packing. So just to summarize the 5 essential facts about CHT, we feel it is the most effective way to remove process impurities. We demonstrated it has a robust and easy method development. It's simple to pack in any diameter column. Additionally, it is environmentally friendly and biodegradable. Supported by a global network of experts, and it is also in many licensed processes worldwide. With that, I'd like to thank you for your time. Just a few notes about Bio-Rad. If you need any method development, we have a worldwide on-site support from our network of experts. We can provide dedicated technical support. We also assist with process transfer and regulatory procedures. If you want to find out any of our additional resources, you can go to bio-rad.com/library, where you can request resin samples, speak to our scientists, view packing tutorials, request a customized seminar. Also, you can email us at process@bio-rad.com. Again, I'd like to thank you for taking the time to listen to me, and I'd be happy to take any questions you might have.
Okay, great. And as a reminder to our audience, you can go ahead and type in your questions for our speaker now. So our first question is, do you have viral clearance data for CHT?
That's a great question, Alex. Yes, we do have viral clearance data for CHT. There's a number of papers that are online, including one by Bio-Rad that was evaluating PEG enhancement of viral clearance on CHT. In those cases, we've seen very good, robust viral clearance, 3 to 4 logs clearance, which is considered significant removal of viruses.
All right, and our next question is, I have observed a yellow area on the top of the column. What is the reason for this, and is there any risk to my process?
That's another great question, Alex. CHT, because of its nature, being able to bind metal ions, what's happening here is that they're either in trace metals left in your buffer salts or maybe a residual media component that's left over. So what that's doing is it's irreversibly binding to the CHT. One good thing about it is, like I said, it's irreversible, so you don't have to worry about it leaching back off into any of your product effluents. But also, because it is irreversible, it will not impact the performance of the column. It just shows this color, so it might not look great, but it's not harming the usage of the CHT at all.
All right, well, it looks like we're running just a bit short on time, so if we don't get to your questions, we'll be passing them along to William, who can follow up with you directly. Please go ahead and continue to type in any questions you have, and we'll get those passed along. The last question for the webcast is, my team and I would like help packing CHT. Do you offer training?
Yes, we do offer training. I have gone throughout the U.S. and sometimes overseas to go on site to do training for customers to make sure that everything's going right, because CHT is a little unique because it is a non-compressible ceramitized media. Additionally, we do have a line of pre-packed columns that I discussed during my talk that range from 5 centimeter to 33 centimeter diameter. So these could also be used if you didn't want to pack that in those dimensions.
Fantastic. Well, thank you so much, William.
All right. Thank you, Alex.
And thank you to our audience for joining us. The recorded version of this webcast will be available for on-demand viewing on our website, and as a registered attendee, you'll receive a follow-up email providing you with a direct link. We look forward to having you join us at future Bioprocess International Ask the Expert webcasts. Look for those announcements in your inbox. Goodbye.